Awesome. So I would introduce AI Ghana to us briefly. So we are actually an NGO based in Ghana. And what we do is that we actually run a community in Ghana that is focused on promoting the use of artificial intelligence in solving real world problems, okay, in Ghana and beyond. So if you ever come across AI Ghana, this is who we are and this is what we do. So below are some of the programs that we normally organize. So we have mentorships, collaborations, and internships. So if you've ever come across any of our mentorship programs, it's one of the things that we do at AI Ghana. And then we have university chapter. This is actually in incubation right now. And so probably in a few months to come, we'll be having chapter meetings in some of the campuses in Ghana. And then we have meetups and conferences, workshops, boot camps, and then hackathons. So some people have won money from us actually. So these are core values that we have, just put it into a word we call deep. It has to do with dedication, education, excellence, and then problem solving. So we have all of these on our website, aighana.org. And this is run by a strong team. We can see that the ratio of male to female is like the women are beating us when it comes to this. So you have more women taking leadership in AI Ghana. It doesn't mean that these are the people who are doing everything, but they run the head, okay, or the sub teams or the subcommittees we have in AI Ghana. All right. So I'll share some interesting facts that I actually extracted from the responses. So when you register, these are the things I was able to extract from the responses. We are not just an AI community, but we actually demonstrated. So I closed the form around 2 p.m. GMT, Ghana time. And then, so we had 54 of the responses being male and 12 being female. So the women, we needed to do more. Okay, so we had more men registering for this event than the women. And then another interesting thing is that we had representation from different countries. And I think this is something that we need to applaud ourselves for, because it's really nice when we see that event is going global or flying outside the shores of Ghana. So we have 54 of the respondents from Ghana, and we have 6 from Nigeria. And I think this is quite impressive. We have 2 responses from Kenya. We love you, our Kenya people. And then 1 from the United Kingdom. I'll not be surprised. This is like influenced by Ndane, who is our speaker for today. And then we have 1 response from Ethiopia, 1 from Zimbabwe, and then 1 from Cameroon. So this is telling us that Ghana is traveling global. So thank you very much. And I think that the next webinar, we should see more countries representing. And then the last thing I did was to extract the most recurring phrases or words in why you want to join the webinar. So we have data science, because data science is really topping. And we have AI. Some are saying that they want to gain knowledge, application. Learn is also one of the words that was kind of recurring in most of the responses. And so, yeah, this is just one of some of the few insights I was able to extract from the responses. Yeah. So I think I would hand over the microphone to Ndane. So I'll do a quick introduction of who she is. So she's actually a data scientist, and she's actually passionate about using data science tools and principles in improving businesses and decision making. So personally, I've worked with her, and I think she's a very astute person and has intense knowledge when it comes to the application of data science. So she'll be taking us through navigating data distribution shifts in machine learning. So if you are new to machine learning or any of these things, I think this is the time for you to probably pay much attention. What we are going to do is that if you have any questions, kindly write them down. At the end of a presentation, I'll give opportunities for you to unmute and then ask your question, or you can equally write your question in the chat area. And then once we are done, she can respond to them. So thank you all very much. And I'll hand over the microphone to Ndane So Ndane, you are welcome. Please take over the microphone. Thank you.
Thank you so much, Joshua. Thank you, AI Ghana. I'm super excited to be joining to speak with your community. Like Joshua has been trying to get me to come, and I'm super excited that I'm finally able to come and speak with your community. Thank you so much for everyone joining from wherever you're joining. I'm super excited to be here. And thank you once again, Joshua, for this opportunity. So I will start with, I'll share my screen. Okay, please give me a minute. Can you see my screen?
Yes, we can.
Yes.
Yeah. Okay, so for today, we'll be talking about navigating data distribution shifts in machine learning. And so the overview of this presentation, which is going to be very brief, but I hope it's going to be interesting, and I'm sure you're going to learn one or two things. So we'll get to know about me. Yes, Joshua already made a brief presentation, so I'll still tell you a little bit about me, and we'll have a brief introduction, and then we'll define like what is data distribution shifts, and we'll see what causes data distribution shifts and recommendations, and we'll have conclusion and take your questions. So yes, that's me. I'm a data scientist. I work with AI applications, data applications. I'm more focused on industry parts. So I help businesses to fine-tune their data to help with business making decisions. And I'm based in France, in Paris. And yes, I speak French and I speak English and other Nigerian languages. I think and one interesting fact about me is I love to watch wrestling. So yes, that's just a whole little brief about me. And I took this picture, interestingly, in Ghana at a conference in Ghana. So I just said that it would be a nice opportunity because it just reminded me of when I visited Ghana. So when we talk about AI, I think first of all, like to show us the video. We'll start with like what is distribution shift. So we have this video of can you see the video playing?
No, I'm not sure.
Okay, can you hear the sound?
No, we cannot.
Okay, anyways, just so that you can just get the gist of what's happening. So this video was taken during COVID-19, during the lockdown. So you can see that the field is empty. And then at that time, you were trying to see how they can allow viewers at home, that's you and I, with our football fans, to be able to have a nice experience, even those that especially for as there was no live audience. So how can they have the online audience, like they were trying to find a replacement for the live audience. So people go to the field to watch. Where you can see that in this case the field is empty, and then they were trying to like stream these sports online. And then we can see that the camera that they use is an AI camera, and the AI camera was supposed to be tracking the ball. But you can see that's the ball. That's the ball. But you can see that the ball is leaving the frame. So I don't know if you're into camera. From time to time on my free time, I work with cameras. But anyway, that's not the point. The point is you're supposed to follow the football. The football is supposed to be tracking it. And this is an AI camera. It's supposed to be tracking it. But you can see that it's tracking the referee's head. The referee's head is bowed. But the AI camera kept coming towards the referee part, and which is not a nice experience for the audience. Imagine you're trying to watch a match and then follow through the match, and you're seeing they're about to score the goal, and then the camera is still coming to the referee. You can see it's going, and it returns to the referee. So it means that there is a problem. The AI is buggy. Why is it mistaking the ball for the referee's head? We wanted it to track the ball, but the AI camera is not tracking the ball, it's tracking the referee's head instead. So this is a problem that is So I'll stop sharing and I'll share again. So you can see that will actually ruin the experience for an online audience if you're an online audience and you're watching it because you're trying to follow the match and then it's ruining the experience for you. So when that happens, that's what they call data distribution shifts. And what is data distribution shifts? It happens when the mode is, it's possible that when you build your model, you have to test it. So you do testing and then you see 90% accuracy, 100% accuracy. Wow, yes, my model is accurate, it's working well. And next thing you deploy into production. So I'm very sure for the AI, for that AI model, that AI that is in that camera, for it to be deployed, of course, the tested it, nobody will want to deploy something that is not functioning. Maybe it had 100% accuracy, who knows? But if it has 100% accuracy, you see that it's overfitting, right? But anyways, it performed very well during production. But why was it performing poorly after deploying? So when you deploy to production, it's actually in the real world case. In our real world case now is we wanted the AI camera to be able to track the football, wanted to enjoy a live football match. But in this case, it was tracking something else. So when that happens, that is what we call data distribution shift. It happens when the model performed well during deployment, but it performs poorly after deploying. So most times it may not be performed well. It may, when you deployed it, maybe at a point in time, it performed well. Then over time, it starts to perform poorly. That is what we call data distribution shift. And it happens because the data that you're using, the data you use to train your model is actually different from the real life, from the actual data, real life data. So the data that we use in our labs, the data we generate, no matter how we try to get it as close to the world, like the real world data, it is most times it is not usually it doesn't really correlate. And the reason, there are different instances. There are times that at the time that you're deploying your model, take for example, if you want to, like ticket prices, now you deploy a model to be able to track ticket prices and or to be able to predict the ticket prices. But you know that ticket prices are seasonal. There are some times that the ticket prices are high, maybe during holiday, like Christmas is coming now. And then there are times that the ticket prices are low. So your model will not be able to accurately, it may be able to accurately predict, maybe depending on the time that you developed your model. So the data that you used, if you developed your model during high ticket prices, then what of when you deployed it when they were low tickets, when people were no longer traveling at that time? Shake and see. So that's a concept drift. Or when you develop an app to be able to predict ride sharing, take for example, like Uber, like an Uber app, and then it will be able to predict that, okay, at what time is it, or what time can I go out? Are you able to predict it? But there's what we call rush hour in the morning when you're going out. There's traffic. I know people in Ghana, people in Accra have been in Accra. There's traffic, usually traffic in the evening, and then there's traffic in the evening when people are returning from work, and in the morning when they are going for work. So this is because the demand is high, and then when you predict your model, probably at the time you developed your model or at the time you captured your data, at that time you didn't consider what will happen when there's traffic and when there's no traffic, and then when you deployed your model, is behaving somehow. But meanwhile, when you tested your model, at the time you tested your model, it gave you 100% accuracy. So that is what we call data distribution shift. It happens when your model performed well during development, but it performed poorly after you deploy to production. That is your testing data is actually different from the real life data, and that's because data changes. And also, most times, at the point of deployment, your model may be acting well, but over time it begins to act poorly. That's because like data changes, and there are so many other things we should be looking at during the course. And the reason why this happens is because of human bias. Naturally, human beings are always biased. We always have tendency to be biased. And it's not our fault that we are biased. We are biased based on our experiences. We are biased based on wherever environments. We are influenced based on our environmental factors. We are influenced based on, there are so many things that influences us. And these machines tend to inherit our bias. So like the data that Joshua shared at the beginning of the slide, it showed that we had more men than women registering for this course, for this class, for this webinar. So if you're deploying a model and then you're trying to see maybe you're trying to deploy a model to be able to, let me say, like you use that data for a hiring model. Of course, the data will naturally predict, like favor the male people, because we actually had more males sign up for this webinar than women. So take, for example, if we're trying to deploy a model that based on the data that we had for this class, maybe you have access to job opportunities. The people that are likely to have access to these jobs, or the people that are likely to be picked for these jobs, are the men, because we had more male that signed up for the webinar than women. So you can already see that because of the data bias, but at the same time, human bias, because we inherit these biases. I have the tendency to be biased to my Nigerian friend or something. And that's because you have bias, you have tendency to bias your family members. All these biases are inbuilt. And then when you come and you're developing your machine learning model now, and take, for example, you've not had other experiences, you will not consider some of these other edge cases. And so by the time you're not deploying your model, you're deploying your model based on your experiences, based on your own environment. And so it affects the behavior of your model in the environment. And then there's also what we call covariance shifts, which was the example that I gave at the beginning of the class. That is the data that you used at the beginning. The data you used when you're training your model is actually different from the data in the real life data, in the real world data. So the data that you used when you're developing your model is different from actually what it is when you come. Maybe you said you're using a car, take for example, and then I don't know if you're familiar with what we call tricycle. And then maybe in my environment, I don't know, like here in France, we don't have tricycle. And I developed a model here to be able to predict cars, take for example, or a moving object on the road. And I go and deploy the model in Nigeria, in Accra. And then it's not able to tell me that, okay, this is a tricycle. Because the data that I used here, or the data that I have available to me, did not consider a tricycle. You understand? And then at that point, my model will start to misbehave. Not because the model was wrong or anything, but because the real life data is actually different from the testing data, the data that I had to develop my model. And also the data can change. We have because people change, human beings change, like different things, data can change. If I developed a model now, we had those days when handsets came out, we were using handsets that had keypads. And then imagine if I developed a model now to detect handsets, and maybe someone still has access to those kind of handsets that has keypads. And then I tell the model will say that's not a handset, because the model that I used, the data that I used this time around was just the one that has screen touch, like now, because that's the screen, that's the kind of phones that we have available. Meanwhile, in the real sense, data changed. Or telephone, if I bring a telephone and I ask the model to, what is this? What is it used for? The model cannot detect it because the data that I used to change, like to develop the model, has already changed. It's not as if the object changed, it's just that the data changed, and over time, data will continue to change. You have different things as the world continues to grow. And then we also have concept drifts, like what you're thinking of yesterday has already changed. Every day we learn new things. So your behavior for yesterday affected your behavior today. So when you have concept drifts, it affects the way you develop your model. Like take for example, when you developed your model during the time of to predict, like let me say, prices of cars, for example. And at the time I developed the model, I didn't factor in inflation. But at the time that I was deploying my model, like, can you predict car prices for me? And I gave it the other factors, which is probably maybe environment, for price of gas, and I developed a car model which was working fine. Then at the time I'm deploying my model now, I didn't consider in inflation. I didn't consider the prices of gas. So by the time I deploy my model now to predict the prices of cars, everything has already, like, inflation has practically affected the cost of things in the market. So you can see that my model will not work well. It's not be able to accurately predict the price of a car for me, because I didn't because the concepts, there's what they call concept drifts. Like, there is now a new change. At the time I was developing my model is different from what is in the environment now. So I'm sure, like, if there's any question, I'll pause for any question. You can ask your questions in the chat. Okay, no question. So there are different types of we have different types of shifts. That's like the data shifts. We have sudden shifts. There are times that suddenly, it may be at the time I deployed my model, immediately there was inflation, and then that one I can immediately see the effects. Or take for example, you're able to predict that, okay, at this time during COVID, we know that at that time businesses were shutting down. So imagine you deploying a model that, oh, by this year, maybe it was during COVID, you just be like, yes, the prices of cars, you're going to make so much money, and then you're making crazy predictions, and then suddenly your COVID now struck. You can see that at that time, COVID affected the way a lot of businesses were running. Businesses had to shut down, they had to go online. But at that time, when I was deploying my model, developing my model at that time, we didn't see it coming. So there's what we call sudden shifts. There are some shifts that you see it suddenly, and then there are some shifts that you see it gradually. Take, for example, if I already deployed my model like maybe years before the COVID happened, and then it was performing well, then suddenly COVID now happened and it affected the way things were run, like maybe businesses were running and so many other things. That's a gradual shift because at a point in time, the model was acting well. But over time, the model stopped, like the model stopped acting well. It started behaving like there was now a gradual, like a different shift. Then there's what we have called as partial shifts. So if I develop my model, depending on the space, like take for example, if I bought a new device now, or some of my users are using mobile phones, some of them are using desktop phones and probably desktop devices, and I didn't consider some of these things. So that is a partial shift. It will affect the experiences of my users on both a mobile device and desktop devices. Or take, for example, if I developed a model for people in Africa, and I think we've seen it over and over again, that's why there is the need for we to rise up and to take ownership of our own technology. That is why AI Ghana is here, because we have to develop our own technology that works for us and for our society, because our society is unique. So if I developed a model here in Europe and I go and deploy it in Ghana or in Nigeria, it won't work because the environment is different, the landscape is different. Probably the way I captured my data is different. The buildings here are different. The way the road is different because we have a tropical region and then we have another region. So many things are different, like so many things, like they're totally different. Probably it's snowing here in Africa, it doesn't snow, and then you want to now go and deploy a model there. Definitely it's not going to work the way I expect it to work. And then we also have temporal shifts. You have the same users, same devices, but their behaviors changes over time. And yes, as people, we keep learning every day. You're not the same person you were yesterday. You're not the same person that you were 2 years ago, and you'll not be the same person that you'll be tomorrow. And imagine you're not developing a model for like a population of 5,000 people or 5 million people, and then you have the same users, the same behavior, but you see that over time their behavior changes. What they wanted has already changed. There's now something new in vogue, and at that time you're not able to properly capture it with your model. But these are some of the shifts that can happen, and I'm sure that that's clear. There's no question. I'll move to the next slide. So how can you remedy some of these things? Like how can you make a change? You can see like the lady picking a flower, changing the direction of the flower, but it's the same flower. So what you can do is you have to train, when you're training your model, you need to consider, think outside the box. And the good thing that organizations are still trying to do this. A lot of people are trying to preach inclusiveness. We are trying to get people from different experiences, different backgrounds to come and work in an organization. The reason is to just try to check for this human bias, because what I'm thinking, I don't want to be biased. I'm not intentionally biased, but because of my experiences are inbuilt in me. So it makes me to think in a particular way. Meanwhile, someone has a different experience based on the person's experiences, based on the person's environment, based on the person's exposure. But if I come and sit with this person and we're able to work together, definitely we'll be able to come up with a model that a more robust model. So when the first thing is you need to train using a lot of data sets from various distributions. If I want to train a model to detect my handsets now, I have to go and consider all forms of handset that ever existed. All the forms of handsets, like phone call devices, everything that ever existed. Then but naturally I won't be thinking of it, and I'll just be like, I just want to, maybe is this one Samsung, or this like just a touch screen. But I need to go and consider telephone. I need to go and consider phone that had keypad from the beginning, Motorola, Nokia, all these kind of phones, like when the time that phones handsets came out, all these flip phones. So I need to consider all these things. So you need to train using a data set from like various distributions. When you talk about, I think there was time that we're talking like but I think it has been, when you Google marriage now, like and you like Google it, Ghana marriage, the Ghana wedding is not usually recognized as the type of wedding yet. And that's because the data that is there online, we don't put our data sets out there. So that way we are not even able to get our own type of data sets. We're able to show what we define as our own types of marriage. So you can see all these kind of these are some of the biases that exist. But when you train your data using like various distributions, you consider everything possible. You work with people from different things, people from different environments. You're able to train your data sets from various distributions. And also because data changes every time, we have new data sets, and at the same time, because your experiences changes over time, it's important for you to retrain your model with new data from the new distribution. So when you see something new, you have to go back and retrain. So you don't just train, you deploy your model and then you go and sleep. It has to be a continuous process. You have to train your model, you have to go back and retrain it, and then you have to go back and retrain it. You can also train your model from scratch. Probably what was applicable before is no longer applicable. Scrap it out, go and train your model again. Or you can also fine tune it. And fine tuning is like is a process that helps you're able to adjust the hyperparameters, the architecture, and then you're optimizing your data so that it's able to work properly on a new data set. So it's more like a transfer learning approach that you're able to like, you already have a model. So that's your existing model, but now you have new data sets. So you just need to like change a little bit in that your model so to be able to fit the existing data set, like by adjusting the hyperparameters, adjusting the architecture, and then you train the data again. So these are some of the ways that you can just try to see that you can have a robust model that can work in at least in almost all situations. Whenever there are changes, you go and retrain your model again to be able to adapt it to fit in the new environment and in the new situation. So I'll stop for questions. Do you have any question? Okay. If there's no question, please move your devices. We're going to have a short quiz. You can go to this site, please. So let me stop sharing and I'll share again.
And I think we need a site again.
Yes, um I'll let me drop the link on the code on the chats.
Right.
Yes.
But I think I have a question on my own whilst you're sharing the link.
Okay.
So with the 3 recommendations that you've given us, when it comes to computation, which of these 3 recommendations is more expensive computationally? Because I'm imagining myself using cloud resources, like let me say AWS, and I have to use virtual machines for this, and I'm paying for the machines. So with these 3 recommendations, which one is more efficient when it comes to computation?
It actually depends on your data set and your type of project that you're working on. But for me, what I will recommend is fine-tuning, or you just retrain as the data set changes. So when you have a new data set, you just retrain your model. So that way your model is not already learning existing data that you already use. It's just learning on the new data set.
Oh, okay.
Yes.
Thank you.
Okay. So I need to know how many people have you been able to access the link. I've shared it on the chat. I'll soon share my screen. Just give me a minute. Oh, are you seeing my screen? No, you're not seeing my screen yet. Okay, so have you been able, please, can you put yes, 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 yes in the chat? Okay, people are already answering. So let me present my screen. People are already answering. Okay, so yeah, so is someone talking? Okay. No more responses. So the next question. Sorry, I'm supposed to be giving explaining this thing. So let's go and do it again. So the first one is the first question is you have to define data distribution shifts, and it's supposed to be a word cloud. So most people, they were not able to sign up on the link. I don't know why, but some people are saying that is time works data changes, yes, model. Some assuming people are saying that it means like data changes with time or a model changes with time. Yes, that's just an example of a data distribution shift. It means the behavior of your model changes with time, and as a result, because of data, it's apparently because of the data. And then which of the following is not a cause of data distribution shifts? Um, we discussed a number of causes that are not, and then I think a number of us got it correctly. Machine loss, we did not discuss machine loss, but we discussed about covariance shifts, we discussed about data changes, and we discussed about human biases. And these are some of the causes. These are the reasons why we have distribution shift, because yes, we have human biases. We are not able to think outside the box and just collect this data or develop the model based on our own experiences. And then covariance shift, your test data is different from the real actual data, and then data changes because data changes over time. So the next question is which one of the following is not a type of data distribution shift? Okay, so one of the following is not a type of data distribution shift. We have sudden shifts, gradual shifts, temporal shifts, and permanent shifts. A number of us got it right. Permanent shifts is not a type of data distribution shift. Sudden shifts, there are times that as soon as you deploy it, you can see like there's a contrast immediately. And that means you didn't actually, there was something you did wrong and you have to check it. But permanent shifts, you can always go back and retrace your steps and retrain your model and then deploy it again. So the answer is permanent shifts. Then how do you think you can solve the problem of data distribution shifts? Okay, I think the time is up. So you can retrain your model. People got to train your model. Then stakeholders collaboration. I'm not really sure who answered this, but I'm not really sure. But if you want to solve it, if there's a data distribution shift, you can go and discuss with your teammates and then try to see how you can work towards it. So the answer is just if you're not working alone, you can discuss with your team to see how you can resolve the problem of data distribution shifts. So that's all for the questions that I have. Thank you so much, everyone, for participating in the quiz. I hope you had fun while participating in the quiz. So for conclusion, during this, for the course of this session, for the course of we're able to talk about data distribution shifts, and we saw that it's a phenomenon that works when the model that you deploy, like say, is the behavior of the model changing over time. So, and it happens probably as a result of human biases, data changes, concept drifts. So when you develop a model and you train your model, and then when you go to deploy it, it's actually not giving you what it was supposed to give. It's actually giving particular manner. That's what we call data distribution shifts. Your model is not behaving properly in production. And then we saw about the different causes, the things that causes data shifts. And then we also saw about how the different types of data shifts. And then we're also able to discuss about what you can do to be able to solve the problem of data shifts. So I think for now, that will bring me to the end of my presentation. If you have any questions, please ask, or you can reach out to me. That's my website. You can send me a message on LinkedIn or Instagram or Twitter, and I'll be happy to answer you. Thank you so much.
Thank you, Ndane. Thank you so much. We still don't have questions. I'm thinking we should have questions. Were there any terms that were new to you, or probably a phrase you want Ndane to probably explain further?
I have a question. My hand is raised.
Oh, I didn't see your hand raised. Sorry. Please go ahead.
Okay. Thanks, Danny, for your wonderful presentation. So I wanted to find out, from the way you explained the sudden shift, and I'm just trying to compare it to overfitting. How would I know the difference? So I trained my model. It was doing well during the training, but all of a sudden when I deployed it, it's not performing well when now new data is coming in. How do I know this is not just a matter of overfitting, and it's as a result of the data shift, the sudden shift of data? How do I know the difference?
So for me, I feel like if your model has a problem, it has a problem. Either you name it overfitting or you name it sudden shifts. These are just terms. And then if you're able to, when you do overfitting, it's because it actually happens a similar thing, like you deploy your model and then it's not able to like when you train your model, it works very well, and then you deploy it and then you see that it's not behaving the same way. Definitely, but you don't want your model to act that same way. You want your model to be able to identify data the way you want it to identify. So whether it's overfitting, whether it's sudden shifts, I won't really recommend that you just like tell me that I'll just like you should just go back and then just try to fix the model so the model is able to work properly. So you can adjust the weights, you can retrain your model again with more data or anything. Because the end goal is just for your model to be able to identify, to work as it's supposed to work. I don't know if that answers your question.
Yeah, one aspect is fine. So if I've overtrained, if my model is overfitting, of course there are some things I could do, some quick fixes, which I am thinking might differ a bit from when you now realize that there's a shift in the data itself later on. I don't know if the way I'll fix my overfitted model is the same as the way I would fix that of the sudden shift in data.
Okay, I didn't really actually go to the technical parts of how you can fix your data shifting, but and I think it has to do with a lot of like you have to do the gradient descent, fix the hyperparameters, and also try to fine tune your model. But I really goes into the technical parts, which is what you would do if you discover your model is overfitting or your model is not working as it should be. But one of the ways that you can also do your like fix your, you have to check maybe the hyperparameters, for example, to be able to see, okay, why is your model not acting very well? Could it be that it's the data? Do you need to retrain your data, or do you need to cross-validate do cross-validation or share your data just so you can have a better fitting model? Because like the goal is one thing that I've learned is as a developer, there are different ways you can solve when your model is not acting in the same way. There are different ways to solve it. So you can troubleshoot and just think wide. Okay, so these are the possible causes. Could it be that it's overfitting? Could it be that there's data that is data drifting? And then you just try to figure out, okay, how can I do to just make my models to work in a particular way that I would like it to work? Because at the end of the day, the end goal is you want your model to be able to work as it should work. I think like for me, that's the approach I would take. I'll try to figure out, okay, what are the possible ways, what are the possible causes, what could actually be happening, and then just try to fix it.
Okay, thank you.
Okay, thank you, John. We still have a couple of minutes. If we still have people on the call who wants to ask questions, it could be anything. Maybe we have, because most of us are students or probably new to machine learning and AI. Maybe there are some concepts that were not too clear to you. You can send a chat or okay. I think Ndane, someone mentioned PCA. I don't know if that is I think Adele, I don't know if that is in response to what John was asking. But then I don't know if there's a way PCA can address the issue or the question that John asked. Is that relevant?
Yes, it's relevant to your situation, because if you're trying to develop your model, you can try to apply like, okay, how can you use PCA to be able to figure out how you make your model to be able to work better and able to predict in a befitting way. So, and it can be like feature engineering. You try to check out the features of the model to be able to see that probably is a way to be able to figure out how your model can work in a particular way.
Okay.
Yes.
All right. So to our new people here, because some people are very new to machine learning, can you probably in a few seconds explain what PCA is? Just in probably the simplest way you can possible.
Okay, the way I understand PCA is you want to reduce the dimensionality of your data sets. It's more like feature extraction. So you're trying to, like, when you have a data set, that times that it has to do with a lot of noise in the data sets. I'm still trying to figure out is an easier way to put it. So you're just trying to reduce the dimensionality of your data set so that you'll be able to figure out like what is the most important feature. Take for example, when you have I'm trying hard not to use the sense of a dog and a cat. So when you're trying to train your model to be able to figure out, okay, what is a dog and what is a cat, or maybe a dog and a cow, there are particular features that make a dog to be a dog and a cat to be a cat. So using PCA, you're able to figure out, like, you're able to reduce the dimensionality and figure out like what are the most important patterns, what are the most important relationships, what actually makes a dog to be a dog, and what makes a cat to be a cat. And then you're able to do it. And it's just like more like dimensionality reduction, basically.
Okay. Yeah. I think I'm getting some kind of response from Adelaide as well, saying that the most important feature. So yeah, thank you. So I think this is like well explained. If there are any more questions, we still have a few minutes. I think I'll take a couple more questions. It could be probably even outside the topic, and that is really experienced. You can really explain them. If it could part anything, just so that we are, satisfied before we leave. If there are any other terms you want us to explain, we have a lot of time for that. If there are any questions as well. I was not so enthused about the ball or about the camera focusing on the bald referee or linesman because I'm bored and I felt like
Oh my God, just
if I'm standing there, probably the AI camera will be focusing on my head instead of the ball. So maybe we need to go back and then I tell the machine that if you see something like this, it's a bald head, it's not a ball. So anyway, so we still have time for questions. Ndane is here. Let's try and extract everything we can get from here. You can raise your hand equally, or you can send a message, and then I can read that one out. But I mean, I think I've enjoyed the session. I've not really, paid attention to data drift. But okay, there's a hand up. Interesting. Please unmute and talk. Oh, that's Adele. Finally, he's talking. Please unmute and talk.
All right. Thank you. Thank you, Joshua. Thank you, Ndane. So quickly, what really is the difference between machine learning? No, what really is the difference between the general way of working on prediction And causation. And I'm asking this question because I'm trying to work on causation, but I feel that I'm having a number of challenges. So I just want Ndane to like just maybe throw or shed more light around how to solve for causation in prediction.
I'm sorry, I don't get the question. Can you rephrase the question a bit?
Okay, I was saying that because you know in machine learning we so sometimes we're predicting, right? And in this instance, I'm talking about prediction.
Yes.
And then we have the general ways of predicting, to train data sets, test it, and all of that. But I'm saying that away from that, in the area of causal inferences, causation, targeting, is there a way you can advise on how to make causation much more um, easier and much more real, like driving it more home rather than being theoretical? So, for example, at work, I'm trying to predict the reason why people are dropping from a particular promotion. Yes, I'll write the normal traditional ML um, query to do all these things. But there's also something called causation to say, oh, okay, people dropped off at this point. This is the weight of this point in relation to the reason why they are dropping off. So I'm saying that how can you shed more light on this? I don't know. I know it's out of the scope of this. Um, Out of the scope of the lecture, but because the child encouraged us to ask questions away from what you discussed.
So your question is how to solve for causation.
Exactly.
Okay, one of the ways that, okay, first of all, when we talk about, there are sometimes, because most of the people, like the audiences, they are beginners, so they may not understand that is high level machine learning. So there's what we call like causal inferences. And when you're developing your model, you want to check like, okay, why is situation happening? Take for example, when I say I have a cold, the first thing you will ask is, why do I have a cold? Did you did I not wear my sweater? Did I expose myself to cold? Did I not drink cold water or hot water? As in, you like to ask like, there's a reason why I'm having cold, and so that's what we call like that's a causal inferences. That's a causative inference, and then you can also call it like there's also what we call correlation. You're able to like relate events. This event is happening because XYZ happened. So an event is dependent on another event. And one of the way you can solve for like causative inference or causal inferences is by generalizing your model or generalizing your class. So it can work in every situation and then it is not dependent on A, B. I don't know if this answers the question.
Yes, this has yes, this is good enough for me to think more. Thank you.
So please, any question? I know that it's like it's high level kind of machine learning.
No, but I think if there's any contribution, John is actually a PhD student thing. I mean, John, do you have any addition? I mean, I've never done anything around that. So yeah, it's like an eye opener. I think Adele has set me up on learning about causation. But is there anything else you want to add, John, on this topic?
Yeah, of course, there could be, I mean, a lot of things to be added, but I don't know, given the time that we have, it might be another time that we have to bring in, an additional topic to further this. But yeah, I feel like she has really digested the thing about data shift and all. So I don't have a new idea apart from what we have.
Yeah. I think maybe Adele, we have to contact you for you to be a resource person to teach us about some of these things. Because I think like causation might be more qualitative than quantitative. I'm thinking, and it would be interesting having a topic on this. I'm thinking it will be something to explore because data shift, like data drift, has really and open my mind. Yeah. Okay. So we have like 8 more minutes, but I think that if there are no more questions, we'll want to thank you all for coming. Even though I think I was expecting a greater number, but it's still a work in progress. We thank you all for joining, especially those joining from other countries. We really appreciate you, because I think in Kenya it's really late by now. I don't know if anyone from Kenya was able to join, but we have our fellow Nigerians here, and that's quite impressive. We had people from Cameroon, Zimbabwe registering, and I just hope that they were able to join us. And Ndane, thank you so much. I know I've been knocking at your door for a couple of weeks now. I thank you. Thank you so much for making time and really doing justice to the topic. And I think personally I've learned a whole lot, and I'm really grateful to you. We want to also thank anyone who was able to make the program a success. Trust me, there was a lot of work going on in the background to make the small meeting a success. So we want to thank AI Ghana and every committee that worked in making this a reality. So please, I'll be sending a small kind of email to ask you to just rate our meeting. It helps us to improve upon our processes and also to do better next time. So please, when you see the email, it will just be like less than a minute, probably some 30 seconds, just 2 questions, just say yes or no, and then that is it. And then we are fine. So thank you all so much. We are really grateful. So normally what happens is that I think Joshua is asking us when the meeting will be held. So we do this the second Saturday of every month. It's still skeptical whether we are going to hold a meeting in December, but there will be likely, because of December, we will likely probably cancel. But then in January, we would resume our meetings. However, we do have physical events as well. So we have the webinar the second Saturday, and then the last Saturday, we have a physical event where we actually meet in person. It's in Ghana, unfortunately, and unfortunately, we don't actually, broadcast it. So I'm really sorry. But we do this in collaboration with some partners that we work with. So we have IoT Hub, who are very supportive when it comes to hosting our physical events. So we do this with them at Reach. So we host at Reach normally in the afternoon. Kofi Annan Center, I think Kofi Annan Indian Center for something. But when you just Google it, Kofi Annan Center at Reach, you should see this. I mean, if you are from another country, you are coming. I don't know if we can host you, but we'll think about that. But it would be lovely to have any of our friends in the other countries joining in our physical events. So normally what we do is that we share the events in a WhatsApp group. I'm not sure how we can do this, but probably in the follow-up email to get your feedback and responses, I might have to add a link to our WhatsApp group to invite you to join. Then when any event is happening, you can have first-hand information to that. So I want to say thank you. If you have any questions in the email that I sent, you can just respond, and then I would answer any question that you may have. Thank you so much. Have a good night, and God bless. Bye.
Bye.
Bye.